Let's talk custom loops and pumps and pump reservoir combos and radiators and the MSI Z690 CarbonEK. And that's Lucky. Lucky's my co-host for today. It's MSI's 35th anniversary, so they sent a golden Lucky around. Lucky is very shiny, very chrome. I hope that's not a prediction of the supply chain issues to come, you know, Mad Max. Probably not. All right, let's dive in. This is a custom loop water cooling that's pretty exciting, so let's take a look. All right, this isn't the first piece of fruit from the MSI and EK partnership. EK, they do custom loop cooling and have for a very long time. Pretty reliable stuff, pretty easy to obtain. A big name. I mean, you can DIY some things, you can cut some corners, but EK is a big and well-known name for custom loop water cooling. And of course, MSI. I mean, so this is the Z690 CarbonEK, and what makes this motherboard special is that it comes with a monoblock for your CPU, your VRM around your CPU, and the primary NVMe. That's the big change for this generation. This is also Z690, so this is going to run with the 11900K, which at the time I'm filming this is the gaming CPU champion. Of course, there's also the i7, which is about $300 from Micro Center. Now, for gaming performance, there's really not a lot of difference between the i7 and the i9 when we're talking about pure gaming performance in terms of stock out-of-the-box performance for either one of those CPUs. And so I think that sort of signals some things that are going on in the market. It's like, oh yes, we have the i9, which is cheaper than it has been it's shockingly cheap. And then we have the i7, which is even more shockingly cheap. Well, both of those would be great in this board. Even if you are not necessarily super comfortable with a custom loop cooling solution, it will shock you how quiet that system can be, even when your i9 CPU is pulling 241 watts. Let's take a look at what you get in the box. This is your loop leak tester. I'll show you how that works in a second. Here is the monoblock. It's just a big old piece of metal. Now, in the box are thermal pads. You're going to be able to use thermal pads for everything but the CPU connection, and for the CPU connection you use thermal paste. You got to pay attention to the directions when you do the installation, or pay attention to the guide. I'll show you what I did, but if this is your first foray into custom loop water cooling, I actually would suggest this, because you pick this board up, you pick a pump up, like this is the EK Quantum, this one's used, I'm sort of servicing it. Here's a nice quad 120 radiator. It's nice and thick, and this is all you need. The pump, some tubing and fittings, the radiator, and everything else is on the motherboard. And then you have a custom loop that you're using for cooling. Now you've got to, ideally place the pump sort of low in the case, and put the radiator somewhere that it's going to work really well in the front or the top of your case. You're going to need a bigger case if you're going to get a big radiator like this. This is overkill even for the i9, but the more radiator you have, the lower RPM the fans can spin, the quieter the machine is, which is a nice touch. Have a really nice premium wireless solution. This is a Wi-Fi 6E solution, so this is the latest and greatest. I have RGB extension cables, more RGB adapter that looks like the Corsair RGB adapter, another Corsair RGB cable, two 6 gigabit per second SATA cables. This is our dusting brush, so we can dust the motherboard if it gets a little bit of dust internally. These are our thermal pads for our monoblock, which we will have to very carefully use. We have our M.2 mounting accessories, a nice keychain screwdriver set. This little bag contains the thermal paste as well as the mounting screws for our monoblock. I'm going to go ahead and set those aside. We have a USB stick that contains all of our drivers. Nice touch, because nobody has a CD-ROM anymore. This is the CPU backplate, including a rubber gasket, which you will also need. With that out of the way, let's take a look at our board. Now, the first thing that jumps out to me about this board is the PCI Express layout. This is a very rare PCI Express layout, especially on a board at this price point. Even though it's a premium price point, because it is a monoblock solution, you're going to pay a little extra for that. This PCIe layout tends to only appear on boards that are yet more expensive. It's a dual PCI Express 5.0 layout. Yes, that's right. You can run 2 GPUs at by 8x8 in a PCI Express 5 configuration. The bottom slot is PCI Express 4, 4 lanes wide, and that goes through the chipset. You see, the Z690 chipset is the first chipset from Intel that has ample amounts of bandwidth. It has the equivalent of 8 PCI Express 4.0 lanes from the CPU to the chipset. 8 lanes of bandwidth. That's awesome. You could run 2 PCI Express 4 NVMe off of the chipset and not bottleneck, in addition to the NVMe slot that goes directly into the CPU, which is also PCI Express 4.0. And that's what you see down here. Now, it looks like that there's no thermal cover here, but that's because it's part of the monoblock. There's also a protective film here, so when you install your M.2, be sure to remove that so that the thermal pad can adhere correctly to the M.2 that you're using. So I really like the PCI Express layout on this board. More slots is always nice, but for desktop form factors, it looks like more and more manufacturers are going to, less is more in terms of PCIe slots and more USB connectivity for peripherals that way, which I guess I kind of get. I mean, the GPUs are basically 3 slots at this point, and with only physically enough room for a maximum of 7 slots on the motherboard, you get 2 GPUs, you've consumed all your slots. And that's exactly what we're working with here. It's giving you the layout spacing so that you could use 2 triple slot GPUs on this, then your case is basically full. At the rear I/O, it's a really interesting I/O layout. We have 4 PCI Express 2.0 slots all the way on the left side, along with our BIOS flashback button. So Intel coming out with the new CPUs, if you want to do something other than the i7K or KF or the i9K or KF, you could do that in this board, although I'm not sure that I'd really recommend it, but you could. We've also got DisplayPort and HDMI. Now, for the iGPU on the 12th gen, I did test with my LG CX OLED 120Hz monster. If you can pick up one of these displays for about $1,000, it's hands down probably the best gaming display that you can get. The HDMI port is labeled HDMI 2.1. The DisplayPort is labeled high as well, but these ports will top out at 4K 60Hz. Even though it's labeled HDMI 2.1, which should support 4K 120Hz variable refresh rate, you can forget that through the iGPU. It's an Intel limitation, it's not really a board limitation, it's just where we are. Then I've got 5 10 gigabit Type A ports, a stack of 4 plus 1 over the Type C, and then I've got a Type C 20 gigabit port. The 2.5 gig NIC on the back is an Intel i225V, so that is a later generation 2.5 gig NIC from Intel. This one works well. Not all 2.5 gig NICs do. Sometimes they're a little sketchy. Sometimes the switch you plug them into is a little sketchy. This one works well. Then we've got our Wi-Fi 6E solution, which is again from Intel. And then we've got our audio solution, a 7.1 solution with optical SPDIF. That audio solution is based around the newer Realtek ALC 4080, so that is a newer audio codec. Now for all that PCI Express bandwidth, if it's not going to slots, where's it going? Well, that's M.2 slots. So in addition to the one that's connected directly to the CPU, there are 4 more. So there's a total of 5 M.2 ports on this motherboard in this layout. 5 M.2 ports, goodness gracious. Now all of those will support Intel RAID. I did a separate video on setting up Intel RAID. There's no special requirements, there's no restriction, there's no license key or any of that nonsense this generation. You want to buy Samsung NVMe? Boom, you got it. You want to buy Kioxia NVMe and use that? That's what we did, those little BG4s, because they're super power efficient. Boom, you got it. If you want to run a crazy Optane RAID array, you can do that. It'll only use the Optane H10 and H20, the 32 gig Optane for caching. You can't use the big Optane drives for caching, which I think is a really dumb software oversight, but hey, it's Intel, what are you going to do? So you could run a pure Optane RAID, meaning that you get some of the M.2 Optanes and you just fill the board up, and then the software treats that like just regular NVMe RAID as opposed to the caching thing. That works, gonna do a video on that later, but not economical, not wise, a lot of overhead with that. Not something I actually recommend. But you could run RAID, not with the Optane cache, but you could run RAID even across the CPU M.2. So if you wanted to run like a RAID 0 of 2 really high performance Samsung 980 Pros, this is the board to do that on. Now you can tell that MSI had to make some choices in terms of their USB layout. A lot of board manufacturers will put that 20 gig USB port on the front panel connection, but as I'm finding with my very expensive cable tester, when you're doing case testing with 20 gigabit front panel, not all cases, a lot of cases don't properly support 20 gig through the front USB-C. It's a little sketchy. So MSI has opted to make their front USB-C connection 10 gigabit. Of course, we have the 30-pin 5 gigabit USB front panel connection as well, and 2 USB 2.0 breakout headers for any kind of internal USB peripherals that you might have, maybe an AIO or something like that. Of course, not an AIO on this motherboard, but you never know. There's power supplies that have an internal USB connection. You never know. This motherboard has a total of 8 4-pin fan headers, 1 at the rear, 4 along the bottom, and 4 along the top, except for this one that's on the front edge, which I'm still going to count as on the top, but it's really on the front edge. Now, in terms of RGB connections, this motherboard does issue an extra 50/50 header at the top in favor of the Corsair connector, the 3-pin connector, as well as the digital RGB header at the top edge. There's no 50/50 header here, but there is a 50/50 RGB header along the bottom, along with another digital header and some other extra accessory connectors. The motherboard has 6 gigabit per second SATA ports at the front edge of the motherboard, and they are all right angle off of the front. Other nice accessories that this motherboard has is a toolless M.2. I've been 3D printing my M.2. If you look at some of my old videos, there's people in the comments freaking out like, he didn't screw down the M.2. So I've made a 3D printed clip, a latch. Screws for M.2 is a crime against humanity. And MSI has really, upped the game with their M.2. Some other vendors have too, to make it toolless for you to install your M.2. It's a great touch, and it's a nice quality of life thing. Another nice quality of life thing is you get the digital diagnostic code readout at the top edge of the motherboard, so there's no danger of it being blocked by an add-in card or an expansion card. Sometimes they show up in the bottom edge of the motherboard, but then if you've got a big GPU or 2 GPUs, it ends up being blocked. So enough about that. Let's do a build. Be sure to save the protective cover in the box if you ever need to mail the motherboard in for RMA. They don't want your CPU, and you'd better put the protective cover back. Now, for installing ye old Monoblock, you're gonna need a sharp knife. Why? So you can cut the thermal pads. Now, as per usual, the thermal pads are different thicknesses. There's a reason for that. So for my particular packing, the 2 that have sort of the dark blue or off blue, those are the thinnest pads, and then these are thicker. And then this pad is the thickest that you only have 1 of. This one is for your M.2. Now the thin one and the thick ones. So the thin ones I think go on the chokes, and the thick ones go on the VRMs. Clever, EK is sticking the RGB cable to the please remove before use sticker because they know everybody forgets. They know. But looking at the bottom here, you can see what we're working with in terms of a thermal connection. We have a big thermal area for the M.2, and then this recessed area for the chokes, and then this area for the VRM. And the VRM on Z690 does run hot. You're gonna wanna make sure it's got a good connection. And then of course for the CPU, good old thermal paste. We won't be using the pads, we'll be using the paste. Now each pad is wide enough, if you cut it correctly, that it will cover both the VRMs and the chokes, but the thinner pad goes on the chokes, and the thicker pad goes on the VRMs. If you do need to use multiple pads, make sure the joint for a pad is not on a component. So if you had something like that, and then you had another piece from here on down, that would be okay. But if you had a pad where it lined up like half on one, half on the other, something kind of like that, where it's not completely covering, you don't want that. Don't do that. Now there is protective coating on both sides. You gotta make sure that you get both sides off it. It can be a little annoying. Now comes your M.2 selection. With the thermal pads in place, we've got to mount the M.2. And it is kind of permanent. I mean, once you install your M.2 in this motherboard, it's not going anywhere. It would be a big deal to take it out. And this is the M.2 that's wired directly into the CPU, so you definitely want to use that M.2 over some of your other M.2 slots. I mean, to be sure, not really a bottleneck because there's so much bandwidth between the Z690 chipset and the CPU, which is great. But, yeah, you do have to sort of live with that. All right, with everything mounted, I'm actually going to go with one of the more difficult to challenge enterprise-grade Samsung SSDs. Now, there's a handy removal tab. You'll want to remove the plastic from the thermal pad before inserting the M.2, and MSI has this really cool toolless holder for your M.2. How awesome is that? Now we need the big thermal pad, which is long enough for 110 millimeters. Now, obviously, you'll want to trim that to fit your M.2. You want to please remove before use. You want to dip into your thermal paste. Either use the thermal paste that came with your motherboard or the good stuff. I'm not implying that ectotherm is not the good stuff. It is, but And then to install the block, we just sort of marvelous. What a good fit. Pro tip, you want to use something you can set the motherboard block on. So, sort of pushing it together. Something like this. See, now my holes line up and the motherboard's weight it just works well. The next ingredient is the rubber pad. And then the next ingredient is the metal pad. You can get that wrong, be sure that your holes line up. Very important. What I like to do is just get the screws hand started. So you want to do just like I did and just sort of get each screw started so that you don't over tighten one side way too much. And you also have the 4 screws for the VRM as well before you really want to tighten things. If you're clumsy like me, notice that your EK kit comes with some extra screws and washers, because this is not something where you want to skip a screw. And I've actually used double washers under each one of the screws. Again, the plastic compression acts kind of like a spring. Now tightening these, you shouldn't over tighten them. Just a little beyond hand tighten should be plenty. And as you tighten, you want to tighten corner to corner, approximately the same number of turns. I'm only tightening about 1/2 to 3/4 of a rotation at a time. And I think 2 full rotations is pushing it. And that should do. You can check the VRM along the edges and make sure that you've got good pad contact. There shouldn't be any visible gaps or spacing. Looks pretty good. If anything, it looks like I've over tightened the screws just a little bit, because if you look at the edge of the board, you can see there's a little bit of a bow in it. So I'm just gonna back off very slightly. We're now ready to install the motherboard in the case and get our fittings and do our radiator and do the rest of the build. So I've selected a fractal design case for this build. I've got the motherboard mounted. All we need now is a pump and a radiator. And the fittings, of course. And the EK Quantum fittings. What else could I use? Now for the memory, I'm using Kingston Beast DDR5, 32 gigabytes. And for the GPU, the MSI Supreme 3080, Supreme X 3080. Because of the cooling, obviously. Now, I am tempted to use a custom loop cooler with the GPU, but that'll have to be another build video. So there's our build, based around the EK Quantum MPG Z690 CarbonEK. This is a great way to start building your own custom loop. If you want 16 cores of ridiculous horsepower, but you also want a whisper quiet system, custom loop is going to be one way that you can do that. This motherboard has adequate pump headers, and you would just need a minimum of accessories. Literally, just a pump, some fittings, some flex tubing, and a radiator, and that's all you need. And you can do that in an afternoon. If you get stuck or have problems, you embark on that journey, come to the Level 1 forums, and I'll try to help you out. But this is a really, really great starter platform. The reason that this is nicer over, versus a water cooling retrofit kit is because this takes the VRM heat and the M.2 heat into account. All of that is connected to that monoblock. Of course, that means you're going to be extra careful with the installation, because you got to make thermal connection with all of that stuff. When you're putting the screws in, you got to be careful, and you make sure not to over tighten it. Make sure to apply even pressure, so that you don't tighten the heatsink down on one side and it's like trying to pop up off the other side. It ends up not being a great situation. There's no spring here. The thing that it's using for its compression force is literally a rubber mat. So don't over tighten it. Be careful with it. Maybe bring over a friend that knows what they're doing if you're totally lost. But this is a great starter platform for custom loop cooling that is an incredibly high-end, simultaneously is an incredibly high-end solution for LGA 1700 Alder Lake, the 12th generation i7 and i9 processors. Even if you're going to do an extreme overclock, I wouldn't recommend this motherboard for the i5, but the $350 i7, if you get it on sale, is a heck of a deal with this board, especially if mainly what you're doing is gaming. If you really want to push the limits of the 12900K, or maybe even that new rumored higher end 12900 SKU, the pre-binned one maybe, that may or may not exist, this wouldn't be a terrible choice for that platform. This is Level 1. Again, thanks to MSI for sending this over. This is pretty awesome, and thanks for Lucky for helping me supervise this build. This is Level 1. I'm signing out, and you can find me in the Level 1 forums.